My name is Sergey Gasilov. I'm a senior scientist at Canadian Light Source, and I have been responsible for biomedical imaging and therapy beamlines for the last 5 years. Our primary technique is X-ray microtomography. We are using X-rays in order to penetrate through optically opaque samples and see what's inside them. We are trying to resolve internal microstructure of the samples at very high spatial resolution, for instance, to see micrometer-sized pores or fibers inside the samples. We are using tomography to do it in 3D, so we don't have to slice the sample to see what's inside it, but we can do it non-destructively. Our most important research is in the domain of biology and preclinical imaging, help researchers find better medication against, for instance, cystic fibrosis and osteoporosis. We work a lot with material scientists to design better materials which can later be used either, for instance, in power sources or batteries or medical implants. We have a very strong agricultural program on the Beamline where people try to optimize, for instance, extraction of oil from canola seeds and optimize resistance of different plants. Thanks to the insane number of photons of flux density, we can do scans extremely fast, which is very important to image when we need to image sensitive samples, which, for instance, dehydrate in the beam. Or we can do actually four-dimensional tomography, that is tomography with spatial and temporal resolution, which is being exploited by people who want to see what's going on inside the system. So it's not just sample, but it's, for instance, can be operating fuel cell or charging, discharging battery or breathing animal. Lastly, we can do ultra-fast imaging to make a slow motion of very fast processes. Again, when objects are opaque for visible light, we can still see what's going on inside it and make sort of a little movie. So we can also manipulate the beam. We can work with monochromatic beam, meaning that we have a much smaller dose in our flux in our beam without sacrificing the quality, and hence we can image, for instance, the same animal several times without exceeding radiation dose limits to find out how new medication changes microstructure of lungs or of a knee joint. I came to work at LS because I wanted to implement all my skills and knowledge, which I have accumulated throughout my PhD and postdoctoral research. I have been trained as an experimental physicist. Here in this environment, I can apply my training and my hands-on experience to help other people to conduct fundamental research. I can participate in experiments. I can design new systems and detectors to advance scientific research. If you ever had ideas and necessity in using X-ray microtomography technique for your research, certainly consider reaching out to us. We can discuss your project and we can make it happen.